Hello and welcome back to another advent of code using jakt programming language on SerenityOS. I'm a couple of days behind. We're on day 15 now. I've not been well, so I'm just taking it easy really. But yeah, we'll get stuck into 15. So I have had a read of some of the problems that are coming up. So I kind of have a rough idea on how I might do it, but we'll get to it. Now this is the example input here, so we can't select. I should really fix that because it would make life a bit easier. But what I am thinking of doing is doing a little Vim golf, so to speak. So we could probably do. I didn't want that. I need to work out where my minus is right there. So what I'm thinking is I can kind of just put in all the input like this, and then use some Vim magic to make the input what the input is meant to look like, because these numbers are the only things that really change, I suppose. Alright, too much talking and I got sidetracked as to where I was. 0, 11 to 10, yep. So yeah, I'll do some Vim magic to get where we are. Which could be kind of interesting. 2, 18, 2, 15, 16, 10, all looking good. And the fact that I got to the end on both sides meant my eyes were in the right place. Yeah, cool. So that is kind of the input. Oh no, I didn't want to do that. I still had a D in my buffer, and then I went back to the starter file and it just deleted to the starter file. So I think for this we need a couple. I'll probably do a couple of macros. So basically one to type in sensor x equals, and then we would skip over a word, then add in the y equals, then skip over a word, then add in the colon up to x equals, like that. So we'll start a macro. Sensor at x equals, and we'll quit out of that, go to the end of the word. Actually no, we'll kill the macro and we'll start it again. Sensor at x equals, and then we'll find the next comma, and then we'll append y equals. Then we'll find the next comma again. I hope they'll work. Yeah, I think that should be fine. And maybe if we delete that and then insert when closest con is at x equals, and then go there again, then y equals, and that, and if we give focus back here, and then escape that, then down and start, and we can see what the macro does. That looks good. So maybe we can do it set number, set relative number, and maybe we can do that 11 more times, maybe one more time. And that gives us our input, which should match up with this input here. Don't know if it does, but hopefully it does. If it has some input, has some issues, we'll find it out. So this can go back maybe there and go off always on top, and there's 26. So what we want is part 1, 26. So I think we need a Hack Studio open, good old trusty Hack Studio, and in Hack Studio we can, not quite that far, and yeah, we can have it about that much. And we're on what, day 15 now. So day 15, the gist is, so we were like exploring some tunnels, and we found like a sand hole, and we seemingly got out of there, I guess, and we had some sensors in our pack of things that the elves gave us. So we have like a device that can kind of work out where a bunch of beacons are. So we've got beacons, and now these beacons know where the sensor is. So like the beacon is tied to one sensor and vice versa, and the sensors only lock on to the closest, the one closest beacon, and there will never be a tie for that, so we don't have to worry about that. And this is a description of where all the beacons, where all the sensors are and where all the beacons are. And so you can kind of get a map like this, and like for example, like this beacon here will be tied to this sensor, and you can kind of, based on that, so that's a Manhattan distance of like 2 across, 1 up, so 3. You can kind of tell that 3 up from it, there won't be anything there, and you'll kind of get like a diamond shape. So to like there, and same down there, around like each of these S's, depending on where the beacon is. And like this one, it's only 1 away, so it'll be a real tiny diamond, basically just the 4 points around it. And you can kind of see that with this example. Interestingly, yeah, I want to see where that is. That's like X is 0 and 11 for the sensor. So 0, 11, closest beacon is at 210. So for this beacon, the closest beacon is at 210. It is this one. Weirdly, it's highlighted this, so I kind of want to, because I think this is kind of implying that this is the beacon for this sensor, but it's really the other way around. Yeah, so we're considering this 8, 7. So 8, 7, and yeah, so it's like the same beacon. So the beacons can, sensors can only lock onto the one beacon closest to the sensor. There is never a tie where 2 beacons are the same distance to the sensor. So a beacon can be attached to multiple sensors, I guess, but they just have to be the closest beacon there. But anyway, so you can kind of get this diamond pattern, and you can, that diamond pattern will still kind of exist. And what we're trying to do is work out, we're trying to work out where the distress beacon isn't, because it's not talking to us. There's one sensor, one beacon that is not, for some reason, sending out a beacon, and that's probably because there's no sensor close enough, I guess. But to solve this, you need to find a particular row. So in the example it's 10, but in the actual it's like 2 million. And at that row you basically want to count how many places the beacon can't be, because it's within that kind of diamond shape of others. So I've got some ideas on how I might do this. We'll need to pass in the input, and I think for this I won't actually generate a map. depending on what part 2 will be, maybe a map will be needed, but I'm kind of tempted to not generate it because, say for example, this B, which will probably be this one. Oh no, that's quite a ways off. It might be this one, but that basically means that this S will actually go out to like here or something in its diamond pattern. So we'll need to work out the bounds of whatever grid we do, or we just don't make a grid and do it a different way. And that's the way I kind of want to go about it. So we're wanting to just get like an individual row. So I think I'm going to make a function to basically get any specific row, and in the example we can just, I don't know, we can see how many points there are, and if there's more than the example we can say go to 2 million, otherwise just go to 10. That way the test times will kind of work. It's a bit gross, but that's alright. So how might we go about this? So say this one here, if we work out this closest one here, it is there, and that is like 1, 2, 3, 4, 5, 6, 7, 8, 9 distant, which it might say, nah, it doesn't. But from that, you can see that it goes up 1, 2, 3, 4, 5, 6, 7, 8. Did I miscount? 1, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. I did miscount. So basically, we can get the scanner and the beacon, work out the Manhattan distance, which is pretty trivial, and then from the scanner, we would then go up that distance, and we can get the point of the triangle there, and down would get that point, and across would get that point, and across would get that point. And based on that, we can kind of filter out which coordinates we want to look at. Because say we want to look at this row 10, say for example we want to look at row 17, we can just disclude this scanner because we know that it's not going to have any effect on this row here, but some of these other scanners will. So we can kind of filter out the scanners that we're looking at based on that Manhattan distance and whether the top and bottom is basically within. We're only really caring about Y because we're only looking at a particular row, and the X's will come into play when we're actually looking at that particular row. Now from that, say we go the full 9 up, that means we're only going to have 1 at that row in the center column. And as we're going to go down rows, we can work out pretty reliably each row is going to add 2 until we get to the center row, which will just get up to the number, and then it'll start decreasing by 2. So using that kind of logic, we can basically map it out, saying where everything is. Now, there might be some overlapping, which we will have to kind of keep into account, like, for example, this, we can like select that maybe. I wonder, yeah, we can do like something weird there. Anyway, sidetracking. What I was saying was basically this scanner here, this diamond will overlap with some parts of this diamond. So we'll need to kind of work out how to deal with overlaps. I think to start with, we will parse the input because that's kind of what we've been doing for the first year. And we'll see how I get on. I don't really want to do too long a video because I've been quite tired recently, yeah, I might just need to give up, but we'll see how I go. It will be good getting something out. Now to actually parse this, what I was thinking, because this this input is kind of gross. But what I could do is actually split the string on equals, because in jakt we can split on a single character, we can't do any string type stuff. And if we do it on equals, then we can see, we can pull out that and it'll have like some extra stuff, and we can pull out this, it'll have some extra stuff, we can pull out this, it'll have some extra stuff. That's alright. So I think we're not going to have a actual parse function on there, and instead each line we can basically create a point, and maybe we can have a couple of arrays, so we can have sensors. I think here we want to have like a struct sensor, and it is going to have a beacon, which is a point, and maybe we can have a sensor which is also a point, actually maybe we can have a pass on this, parse, and take an anonymous string like that. This is going to throw because it will most likely throw, and we can return a sensor like that. And this can just be an array of sensors, and we can kind of initialize that, and we can sensors.push sensor pass, and we can give it that line, and we can get rid of that. Right, so how we do this, as I mentioned, we're going to have like a split of the string on the equals character, and then here we can kind of construct some points. So we can like let this sensor equal a point of, now here we might go like this, and here we can have split. This is going to be the first split, and we're going to split that again on a comma and take the first, and then go to int bang is bang I64, and then the y is going to be split 2, and here we're going to split on colon and get the first of that, and to int bang is bang I64, and that is our sensor. And we can probably also let beacon equals a new point, not point, and this is going to be our split 3 now, and here we're also going to split on a comma to strip that, and then we're going to int that as bang I64, and we probably need to do that, and here we can just go to split 4, which will be, so this is 0, that's 1, that's 2, that's 3, up to there, and then that's 4, and there shouldn't be anything after, so we could probably just go to int bang is bang I64, and here we can just return a new sensor with sensor and beacon, I guess, and that is the parse function, and I think I might want to make that a bit bigger, and we can kind of just go between the two as it comes. So I think here I want to like create a distance function, function distance, and it's going to return just an I64, and I think this can just return what do we have? So we probably want to pull in ABS, and I think I kind of just want to make another function on the point, which will take this, and it will take like in a non point, and this will return I64, and this can just return ABS this dot x minus p dot x plus ABS this dot y minus p dot y, and here this will also take this, and this can just return this dot sensor dot distance this dot beacon, and then we can kind of just hide the XY, even though we kind of do the XY on here, but yeah, that's cool. Right, so from that distance, we also kind of want maybe a function outside of this to like generate a row. Yeah, and that generate a row will probably return a thing. So we could potentially draw the map as is. Yeah. What do I want to do? Yeah. Should I draw a map just to double check that I've got everything? Yeah, function print map, and it can take a we could probably just call it that sensors, and it'll take an array of sensor, and it'll probably throws. Now here we want to work out the like min max, I guess. So to get that, we basically need to work out. Yeah, so I guess here we'll have no, I don't think I'll do that just yet. Something here, stop itching my hand. Alright, so to do this, we need to basically work out the bounding box of all of this, and I'm wondering whether we kind of work that out in the parsing, or we just do it here when we print it. I think we'll just do it when we print it, because we don't really need it anywhere else, only to print really. So we'll have a mute x1, and this can probably just be the first sensor like that, and x2 can be the same, and I didn't want that, I wanted that, and then we get the y's, that's on this keyboard. So we're making an assumption that we have one element, and here we can probably for sensor and sensors, and here if sensor dot x is less than x1, yeah, we'll just do it like that. We can go x1 equals sensor dot. I might just call that s. Sensor dot x, and if s dot beacon dot x is less than x1, then x1 can be s dot beacon dot x, and also we probably want to check sensor dot y, and if that's less than that. So I think, just because it's going to be a bit bigger here, what I kind of want to do is x1 equal min of x1 sensor s.sensor.x, something like that. And I think in our helpers we'll add a min. So in helpers we can just have function min, and this will take maybe a non a I64 and a non b I64, and it'll just return an I64. And here, if a is less than b, we can return a, otherwise we can return b. So that just makes that a bit easier. And here, wherever we did that, we can basically do this, and that can be beacon, and we can do the same with the y's, except with y's. And I think I'll also want to do a max, so we can do that, and then max can just kind of do that, and that means we'll also need to get the max there. And here we can just kind of collect all this and maybe have the 2's here and the 2's here, and yeah, so, and we'll also need to change that to max. Alright, and I'm just going to add a to-do finish this, because yeah, I'm getting a bit